Uh, Welcome to the tech session on creating custom images on Google Cloud using HashiCorp Packer. In this session, we'll get an overview and an understanding of how the different components of Packer, like we have builders, provisioners, post processors, which work together to generate our desired images. So the agenda will be what is HashiCorp Packer, its features and components, the Packer workflow, and a small demo on Google Cloud. So what is Packer? Packer is a DevOps tool from HashiCorp that builds automated machine images. So you may be knowing HashiCorp, they have these awesome DevOps tools. Like most of us know about Terraform, and also they have Nomad, which is Kubernetes as a service. So and now let's ask what is a machine image. A machine image is what essentially used to be called as a golden image previously, like which is a resource that stores all of data needed to deploy a new image based upon a pre-configured distribution. So that pre-configured distribution may be CentOS, Ubuntu, or SUSE Linux. So that would contain all the configurations, permissions, and metadata needed to create a VM on your platform of choice. So traditionally we used to call the images as golden images, but of lately we refer to them as machine images. So Packer also helps us create machine images by leveraging tools that we already know and we already use. Like for example, Packer is cloud agnostic in the sense it supports most of the major public cloud providers. For example, AWS, GCP, Azure, and Oracle Cloud. And for provisioning, it can leverage our contemporary these configuration management tools like Chef, Puppet, or Ansible. It also supports Terraform, and also its installation supports multiple OS distributions for Linux, Windows, and Mac. And in case of its domain-specific language, it is HCL, which is HashiCorp's configuration language. It is similar to what we code in Terraform. It also supports JSON, but we prefer HCL since it's more human readable. So yeah, this is an introductory overview of what Packer is. So why we should use Packer? So here we may have a question that why we need to use Packer instead of machine image creation tools that we already have in the cloud platforms, like we go to the console and create it manually, or like why we need to use a configuration. But the main reason is uh, why we need to use Packer is the same as why we need to use a configuration management tool. The moment we create an image manually in any cloud platform, to update the images with new configuration is a very tedious task. So, like similar to Terraform, if we have a declarative code template of Packer, we can just describe the uh, desired machine image in it, and Packer generates the image for us. And the second thing is Packer fits nicely with existing CI/CD pipelines. It can integrate well with Jenkins, GitLab, so that makes our CI/CD pipelines very consistent throughout. And the third point is we can create identical machine images which are cross cloud, cross environment, or cross platform. Means a single Packer template can create machine images for multiple use cases. We'll break down Packer and see what a Packer image is made of. So the first thing is builders. Builders is some similar to what uh, we call as providers in Terraform. Uh, like it describes the platform that we're using. We can see the type as Amazon EBS means like we can position this in AWS. Uh, It also includes the desired source images. You can see the source AMI code there, which references AMI means Amazon Machine Images, and also some API key informations and all the other necessary stuff. So that's all about builders, and we have provisioners. Uh, Provisioners are, let us define how to configure the image. Most likely, like by using existing configuration management platforms, for example, Chef, Puppet, etc. Or we can simply use scripts like a bash script or a file provisioner that we can simply upload files from our local machine. Uh, and nice thing about provisioners is it lets us leverage what we already have. Like if you have an entire setup written in Chef, just use the setup written in Chef to provision your AMI or machine image. Beyond the provisioners, after the build has run sometimes, we also need to make some changes. Maybe like we need to upload an image someplace, or we have some specific metadata that we want to supply. And in that case, we have what we call a post processor. So these post processors are directly related to builders and they run after the image is built. Generally, it generates or supplies artifacts. So, for example, for AWS, and your builder is like AWS EBS builder, then your post processor is most likely going to be related to Amazon. In this case, for your example, we have Amazon, the type as Amazon import post processor, which will take all of our metadata generated from our build and import it into a bucket. And post processors really have a wide variety of functions, unlike provisioners and builders, which have a very limited functionality. What the post processor will do is going to depend on platform and its functionalities. So this was all about post processor. Now we have another component named as a communicator. So communicator is that component through which Packer is going to work on the machine that is spun up temporarily to build your image. So when Packer builds your image, it will spin up your source image as an instance. So for example, EC2, then it will make all of the provisioning changes. It will images that instance and then it will delete that instance because we have the image based on it. And in order for Packer to actually connect to that image, we need to provide a communicator for it. Now, by default, we don't actually have to define this because it assumes the default as SSH always. And we need to just provision an SSH username. But if we are deviating from Unix systems, like for example, we are using Windows, then you have to supply this WinRM communicator instead. So these are the like four main components they would expect to see in a general Packer build. Those sometimes do not.
Shivling, your screen sharing got off.
What?
Your screen sharing stopped.
Okay. Now it's visible, right?
Yeah, Shiv.
Yes.
Yeah. So yeah, usually like you would not expect to see a in a general Packer build, like you'll not notice a communicator since it is just a SSH username. So this is like for specific Windows use cases, we should like specifically use this communicator snippet. So like since Packer like supports for various flavors like various Linux flavors, Windows and Mac, this will be the links for installation for your reference. And this is the official documentation that I provided. So yeah, we'll do a small demo on Google Cloud, like building a Google Compute image with Packer. So we are in the CPS6 Cloud Console. So let's see whether Packer is already installed. So we have the Packer, and these are the available commands. Like we have the Packer build, which builds images from the template that we give. We have the Packer format. We have the Packer init, like which is similar to Terraform init, and we have Packer HCL to upgrade. Like if you have a old Packer templates written in JSON, then we can uh, transform them into HCL2 configurations. And the other commands is packer validate, which will validate whether the existing configuration is valid, like whether there are no syntactical errors or not. So first thing what I will do is I will clone a sample uh, Git repository which contains some static website files. So we got the content HashiCorp packer directories. So we'll create a sample directory and we'll copy all the contents in this directory. So we'll change the directory to packer book site. So we'll see whether we are authorized with affiliated service account. So we'll set the account to a service account which I have created specifically for this. Yeah, here is the account. So now we need to create a service account key for this so that Packer can make use of the service account to provision the image. We'll give the name as account.json. So we need to activate before that. I think we already have the account.json. Yeah, now we are authorized. So the key is created now. Yes. So we can see the service account credentials. And now what we need to do is we need to create a packer template. So we'll create an empty file called packer.json. Already have the code with me. So like this will reference a builder as we discussed. Like in the previous example, we saw like a AWS EVS back builder. Now we have a Google Compute one. So we need to give the project ID. The account file will be the service account key, and the source image family here will be using an Ubuntu 2004 based one, and the zone will be at US Central 1A, and this is username will be root, and these will be the image name that I'll be giving a demo packer, a small description. These will be labels like for what role and the team. And here are the provisions. This is a simple shell provisioner which will like create a directory called var www.html, and another file provisioner like where it will suggest it should transfer the files from a website directory to the var www.html directory. And in this another shell provisioner, we have a small script deploy.sh. So this script has commands to install an Apache server, like and has I'll show you. So yeah, this like we have the owner permissions for appropriate website files and Apache start and enable setup to start on boot. So yeah, so now what we need to do is we need to validate whether the code is proper. It says the configuration is valid, and now we'll build that template. So it may take some few minutes, 2 to 3 minutes. It says it's using an image 2004. And what it does is it will create an instance first. If you check here in the computation and VM instances, you can see this. The IPs are matching if you see 35.223.113.69. So it will run an instance first and will capture the image. So it's using SSH as the communicator as we discussed earlier. And again it deletes the instance after it is created. So only the image disk remains. It's completed after 3 minutes. So if we go to the under storage, if we go to images, so we can see demo packer which was provisioned. So similarly, like we can provision across clouds. So if we have a single source template, then it would be easy. Like we can automate this image creation instead of each time manually going and creating the image ourselves. So this was all about this tech session today. If you have any queries, you can ask. Any questions?
No, Shivling.
No, Shubham.
Yeah. Thank you.
Thank you,
Thank you.
Shubham.
Yeah. Thank you.
Yeah, thank you.
Aditya, I have stopped presenting.